Hello everyone, welcome to my session from VMs to managed pools. The session today will be focusing on beginners, but I hope that experienced developers and engineers will also do one or other thing. So the plan for today is that first we start with the basics and talk about what an Azure Pipeline Agent is and why we need one. And then we look into the hosting options we have for our agent. First, we're going to look into the Microsoft hosted agents, and then we have 3 different options for our self-hosted agents. If you're interested in the presentation or the slides, you can scan the QR code, or you can also go to my GitHub. You just search for my name and you will find the slides there. Before we get started, a couple sentences about myself. My name is Wolfgang Ofner. I'm a freelance cloud architect. I'm based in Toronto, Canada, and I'm focusing on Azure, especially security, architecture, and governance lately, but also Kubernetes and DevOps. If you're interested in these topics, you can find more about it on my blog. And I've also started a YouTube channel this year where I talk a lot about DevOps and Azure. And with this, let's get started. So the first question we have is, why do we even need an Azure Pipeline Agent? And there are many reasons, but the first one is we want a piece of software that can run code. For example, if we check in our code, we don't want to use our own machine to run the code. It should be somewhere independent. And this is exactly what the agent does. And with this, we also have to install software on the agent. For example, if our agent is supposed to build a Docker image, then we have to install the Docker CLI. Or if you want to build .NET applications, we have to install the .NET SDK. A big reason why we're using agents and pipelines is we want to have automation. So if a developer checks in new code, then we want to automatically build the application, run unit tests, maybe deploy the application, and everything should be done by code, not manually by the developers. And all of this wouldn't be possible without the agents. And additionally, we want to scale our agents. So if you have a big team and our developers are working hard, checking in a lot of code, deploying many features, then we want to scale out our agents to have as many agents as we need. And that's not a problem at all. So if we run out of agents, we just add more. This means we have more compute power, and we can build and deploy our applications easily. And another big factor, especially when it comes to deployments, is we want to know who deployed what and when. So if we do it manually, we don't know who deployed what. And with a pipeline, we always have this audit log. So we know exactly when did we do the last deployment, where did the deployment go, and did everything go as expected, or did something happen? And with this, we have 2 options how we host our agents. The first one is Microsoft hosted agents, and the second one is self-hosted agents. So let's first take a look at the Microsoft hosted agents. As the name suggests, Microsoft takes care of this agent, and they offer Ubuntu agents, Windows, and macOS agents. This means I, as a developer, just pick the one I need, and Microsoft takes care of the rest. And this is very easy. On the next slide, we're going to see I only have to select one in the pipeline, and then Microsoft provisions one. They already have the software pre-installed, and it just runs. So if you take a look how this looks. So here we have our pipeline, and here under pool, we select a VM image, and there we enter whatever we want. So in this case, we have an Ubuntu version. Down here, we have macOS, and all the way on the bottom, we have Windows. And in this case, we're using the latest version, but we can also specify what version we want. So for example, with Ubuntu, we can say we want 20.04 or 22.04. And so we can control what version we're using for our agent. Then I already mentioned these agents come with pre-installed software, and that's the most commonly used software. So we can build Docker images, we can build the most common applications like .NET, Java, C++, and we also have like NPM, NuGet, and almost everything we want already pre-installed. And since everything is taken care of by Microsoft, it's very cost effective because I don't have to create the agent, I don't have to update them, I don't have to test them, I just use them. And if I don't have any exotic use cases, then that's most of the time enough for me to at least get started. But as everywhere where there are upsides, there are also downsides. And there are a couple limitations with the Microsoft hosted agents. And the first one is that we get a new agent every time we run a pipeline job. This can be no problem, but it also slows down the execution. For example, if you build a Docker image, a big advantage of Docker is that we have caching. So if nothing changes, then we can take everything from the cache and the build should be done in a couple seconds. But since we get a new agent, we all the time have to rebuild the image and can't use caching. Then I said an advantage is the pre-installed software, but this can also be a disadvantage, especially if I want to run software that's not installed. And sometimes you have software that you can't install via CLI, so you would need access on the build agent, and that's not possible with the Microsoft hosted agents. So in this case, you wouldn't be able to use them. And also, these agents come with limited resources. This means we have 2 CPU cores, I think 7 GB of RAM and 14 GB of hard disk or SSD. And if we need more, or if we have a big image and it takes too long, then the Microsoft hosted agent might be not the best solution. Another downside, especially when you want to have secure deployments and you want to integrate the agent inside your network so you don't need public access to your network, then you can't use the hosted agent because the hosted agent only can deploy, for example, to Azure via the internet. And you can't integrate them in your network. And if that's a requirement, you can't use them. And another downside is the limited execution time. We'll see in the next slide the different tiers. There's a paid version and a free version, and the free version only can run up to 60 minutes. And after 60 minutes, the pipeline will cancel. If you have an open source project or a paid version, then you can run up to 6 hours. But the 6 hours is a hard limit. So if you need even more execution time, then it will also be cancelled. And now let's talk about the costs. As I said, we have a free tier, and this means every organization gets one agent with 1,800 minutes per month for free. So you can use this agent, but if you run out of this 1,800 minutes, you can't use it until the end of the month. And to circumvent this, or one more thing is, if you have a public project, then you get 10 agents with unlimited minutes for free. So most of the time, images are public projects are hosted on GitHub, but you could also use Azure DevOps to do that, and then you get the agents. If these free agents are not enough for you, you can also buy additional ones, and here it's a bit confusing in Azure DevOps. So you don't buy the agent directly, you buy parallel jobs, and with these parallel jobs comes an agent. So by default, you have the license for one parallel job with one agent. And if you buy another agent, you get another parallel job. This means you can run 2 jobs at the same time. And if you buy more agents, then you can run more jobs at the same time. These additional agents cost $40 each per month, and they come with unlimited minutes. So you can run them for as long as you want, up to the 6 hours. Then a new job has to start. And on the other side, to the Microsoft hosted agents, we have the self-hosted agents. And a big advantage is that we have full control over the agent. So we can say, what operating system do we want? What software do we want to install on it? We can, for example, if it's a Windows VM, RDP into this VM, install any software we want, and then have the agent use this software. I just said this, whatever software you need, as long as you can install it on the OS, you can install it for the agent. And you can use whatever hardware you want. So if you have a beefy server somewhere standing around, you can just install an agent and then build all your images, hopefully quite fast, or at least faster than with the Microsoft hosted agents. And there's also no execution time limit. So if you have very long running tasks, or maybe you have millions of tests that run overnight, then you don't run into an execution time limit, so they can run all night long if they have to. And since you have full control over the OS, you can integrate them easily with your own network and then have deployments over private connections and don't have to rely on the internet. And again, since you can select whatever OS you want, you can select any version of Linux, Windows, or Mac OS. And again, not everything is perfect, so there are some limitations. And the first limitation is, since you're responsible for the agent, you have to take care of it. This means you have to install updates on the OS, on your agent, on the software you're using. For example, .NET has a new version every year, so you have to install the new version once it's released. Then you also have to pay for the infrastructure. Since you're either running it on premise or maybe hosting something in the cloud, you have to pay for it. And also with the scalability. So if you run out of resources, you have to make sure that you have a process in place to add more resources, scale out, add more agents, whatever you need, but nobody's helping you here. So everything is up to you. And also, since you're running the server and the agent, you are responsible for monitoring it. So you have to make sure that you don't run out of resources or have one project taking all the CPU and RAM and staff the other projects you have on this agent. And the costs, it's quite similar to the Microsoft hosted one. Again, you have one parallel job per organization for free. But if you need more than this one, you can either use your Visual Studio Enterprise licenses if you have any. So for every user with a Visual Studio Enterprise license inside your organization, you get an additional free parallel job. And if you need more, then you can buy them for $15 per parallel job per month. The reason why it's cheaper than the Microsoft hosted one is because you have to take care of the infrastructure and you're using your own server. And obviously, when you calculate the costs, you have to calculate the cost of your infrastructure. This means the server, but also the time you need to update the agent for the maintenance work, and if there are any problems to figure out what's wrong. And now we take a look at a couple options we have, how we can host our agents ourselves. So the first option would be to host them on virtual machines. And this option exists for as long as I can think. And in many companies, that's the go-to solution if they need self-hosting agents. The reason why it's the go-to solution is it's so ingrained into the developers. They need an agent. This means they need a VM. But it's also very simple to do. But it might not be the best solution. And at the end of this talk, you will see a better solution, at least in my opinion, how we can leverage Azure to have the advantage of the power of the VM, but also have Microsoft take care of everything. But for now, if we use a VM to host our agent, we have full control over the infrastructure. This means we can install whatever software we need and we can run it wherever we want. And we can also have as much CPU and RAM as we need. I just said this, we can install any software and also we can do caching. Since this agent is not restarted or recreated after every pipeline is run, we can have caching, we can download big files, have them already on the server, and this might speed up the build dramatically. Since we create the VM, we can easily integrate it in our network and have a secure connection from the agent to wherever the agent is deploying to. And I said before that Microsoft takes care of the scaling if we have Microsoft hosted agents. And if we use VMs in Azure, we can leverage at least Azure to help us with the scaling. So in Azure, we have virtual machine scale sets or VMSS, and they're a replica of our VM. So for example, if we run out of resources of our one VM, we can add a copy. So we have 2, 3, or even more VMs. And then we have a load balancer, and the load balancer takes care to send the requests appropriately to the VMs. Then the downside of hosting the agents on VMs is that we have to take care of the software. We have to install updates. We have to install security patches on the OS, and it might take a lot of work to keep everything up to date and running. Then another downside is that the hardware is often underutilized. So for example, if we have 50 developers, they work 9 to 5. So we use all of the hardware from 9 to 5. But then on the weekends or at night, we have only a handful of tests running. So maybe we only need 10% of the resources we have. But we still pay for everything. And this can lead to very expensive infrastructure. Obviously, if you're using the cloud, we can add more VMs during the day, remove them during the night, but it's still quite expensive. And also with the time you have to factor in to take care of everything, it might be not the best solution, especially with the costs. Another problem I've seen often in organizations is that developers create VMs, install the agents, and then they forget about everything. This means the OS is not patched, the VM is available over the internet, SSH or RDP ports are open, and it's very insecure. And this could be a big problem if an attacker gains access to your pipeline, because that's the centerpiece of your entire code environment. So an attacker could gain access to the code, but also to the deployments. And therefore, it's crucial that you keep it secure. But security often comes with cost, at least with the work time. And you also have to factor this in when you think about using VMs to host your agents. Then another option would be to put the agent into a container and then run it in one of the container services we have. The big advantage is we can still install all the software we need. We just have to add it in a Docker file. So if you take a look at the Docker file, there you can see here on the top, we're using Ubuntu 24.04, and then we install whatever software we need. For example, down here, we're installing Git. Then here we have the .NET SDK, and all the way down here, we have Podman. And then you can build this image, and then you can use the agent the same way as if it was running on a VM. A big advantage of Docker or containers in general is it's very easy to test locally. So you just spin up the container, and if everything works, you just delete it, and it looks like it has never happened on your computer. So you don't have to install all the software, the dependencies, and it's also very easy to share the image. The most commonly used services in Azure are Kubernetes or the Azure Container Apps. And they both come with advantages and disadvantages. Running them in Azure Kubernetes Service might make sense if you already have a Kubernetes cluster. So you might just create a new namespace and then deploy your agent there and use the already existing infrastructure. Another option would be to use the Azure Container Apps. If you don't know the Azure Container Apps, that's basically an abstracted version of Kubernetes. This means Microsoft takes care of all the Kubernetes networking and all the plumbing, and you can just run your container there. And an additional advantage is that you get, I think, 300,000 CPU seconds per month for free. So if you don't use your agent too much, you can run the agent completely for free there. And another advantage is that we can use Keda, the Kubernetes event-driven architecture to scale our agent to zero. This means if our agent is not needed, then we just scale it to zero. This means no agent is running. And whenever we start a pipeline, Keda will check this and then automatically start as many agents as we need. And this allows for optimal usage of our resources. And there also to keep the cost low and only pay for whatever we need. And the biggest advantage of this is, as I said, the costs are quite minimal because often you already have a Kubernetes cluster agent there, or you use the container apps and can take advantage of the free tier. But this approach also comes with a lot of downsides. So the first one is obviously you have to know how containers work and you have to be proficient enough to do some basic debugging and find out what's wrong if something doesn't work. Another probably bigger problem is that you can't do Docker in Docker. So what this means is you can't use your agent in a container to build a Docker file. Kubernetes dropped the Docker shim runtime a couple years ago, and therefore you can't build Docker images right now. A workaround would be to use Podman, but this only works if you run your container in the privileged mode. And for security reasons, you don't want to do this. And with Azure Container Apps, you don't even have the option to run them in privileged mode. And so it's not possible to build Docker images with an agent inside a container. And also, if you're using Kubernetes, probably a better approach might be to use GitOps. So with GitOps, you have an agent running inside your Kubernetes cluster, and this agent monitors a Git repository. And if something changes in this Git repository, then the agent downloads the changes and applies them automatically. And this also prevents configuration drift. This means if I change something by hand on my cluster, then the agent sees that the current configuration is different than the one in the Git repository and downloads again the files from the Git repository and applies them automatically. The biggest GitOps tools are Flux and Argo CD. Both are open source and both work great. And again, since we start a new agent, every time we run our pipeline, we don't have any caching. And as you can see, there are quite a lot of downsides for running agents in containers. And what I've seen in the past is that organizations use this approach if they have small deployments. For example, push some code to an Azure App Service or into a Key Vault. It's usually nothing big, and they also don't use the agents to build software. And this leads us to the last option I want to show you, and that's, in my opinion, one of the best features we have in Azure in general, and also the best options to host our agents. And that's the managed DevOps pools. And the way it works is we have a serverless virtual machine. This means we select what VM we want, and then Microsoft takes care of everything. This means Microsoft installs the agent on it, makes sure that the VM is up to date, and also starts and configures the agent. We don't have to configure anything. So right now we have agents for Windows and Linux. So if you're using Mac OS, you can't use this. But you can also use your custom image. And this allows you to install whatever software you need. And then when you create your managed DevOps pool, you just select your custom image. And then again, Microsoft takes care to install the agent on your image, configure it, and then run it when you execute a pipeline. And this service also integrates with your network. So if you need secure deployments, then you can easily integrate it with your VNet and connect to other Azure services over a private connection. And as I said before, I think that's the best option we have right now for self-hosted agents, because it gives us the power of virtual machines and combines it with the management of Microsoft. so we don't have to take care of anything. One maybe downside is that this feature or service is GA since November 2024. And if you have been using Microsoft in the past, then you know that new features always come with some teething issues. For example, I had a big issue in January 2025, and there I couldn't create a managed DevOps pool for the entire tenant. And then I posted this on the Microsoft forums, and quite a lot of people replied that they have the same issue within a couple days, but then Microsoft fixed it within a week. But here and there are small bugs, which is, if you have worked with Azure, it's to be expected, but Microsoft has a lot of focus on it and the bugs get fixed quite quickly. And there are also a lot of features coming this year. And as said before, a big advantage is of using the power of a VM while Microsoft takes care of it. And this also means that we only pay for the time an agent is running. This means we can have the most powerful VMs and speed up our builds because we only pay for the time the agent runs. For example, if we have a VM with 100 CPU cores, a terabyte of RAM, it runs for 10 minutes, then we pay, I don't know, $2-3 for this 10 minutes, but we have a very fast build. But the downside of this approach, again, is no caching. So if caching is very important, then there's another option I'm going to talk about in a minute. And there's also a startup time. Since Microsoft has to provision the agent, it takes a couple minutes. In my experience, it almost always takes around 3 minutes, but according to the documentation, it can also take up to 15 minutes. And I just said, you can use the most powerful VMs because you are only using them for a couple minutes if your pipelines are not too long running. And even if you have long running pipelines, using very powerful VMs might speed them up by quite a lot, and it might help your developers to get feedback faster. If this approach doesn't work for you, then you can use a standby agent. And this means that you have one VM running, and whenever you have a pipeline started, then the agent immediately picks up this pipeline. The downside, obviously, since the agent is running all the time, you have to pay for the agent. But you could also do a mix. So you could have one agent running and then have automatic scaling. So if this one agent is not enough, you add more agents on the fly. So the first job always gets executed immediately, and then you have to wait a couple minutes for the additional jobs. And you can also have a mix. So you can configure your business hours. So you can say, I have a standby agent from 9 to 5, Monday to Friday, and at night or on the weekends, I just run the agents whenever I need them. Or you can also let Microsoft decide. So they are going to analyze your use case or your usage. They use some machine learning and then decide what fits your organization best. And I already said there are more features coming this year. So the next features are going to be to use spot VMs. Spot VMs are super cheap. So we get up to, I think, 80 or 90% discount, but they could be terminated at any time. So if you don't mind that your pipeline might be canceled and you have to restart it, then this could be a great option to save even more money. And we're also going to be able to use our own container images as an agent. And now, before I run out of time, let's take a look at the Azure portal, how we can create this agent. And then we're also going to take a look at an Azure DevOps pipeline, how we build a Docker file with the previously created agent. I'm almost out of time, but you will see how fast and how easy it is to create a managed DevOps pool. So we're here in the Azure portal, and you can search on the top for managed DevOps pools. And then you can say create managed DevOps pool. Then you create a resource group. Let's call it demo. Then we also have to create a dev center and dev center project. And that's just some behind the scenes infrastructure, and it manages the infrastructure we need for our managed DevOps pool. So we just create a new one, and I'm very bad at naming, so I'll just name it Dev Center and Dev Center Project. Then you provide the URL to Azure DevOps organization. So for me, that's programming with Wolfgang. For you, obviously, that's going to be different. And then you provide a name for an agent pool. And the deployment will automatically create this agent pool in your DevOps organization and then add the agent there. So I already prepared a name for it. It's taking a couple seconds to evaluate. And here's one of the teething problems I mentioned before. I used this name in the past for a demo, and then I deleted the agent pool, but somehow Azure still thinks that this agent pool is around, although it's not around. So I just have to provide a different name, and also sometimes it's not picking up. Like I changed the name right now, and it takes a while to update and figure out that something has changed. Then we configure the amount of maximum agents we want. So if we scale out until how many agents do you want to scale? For example, I just use 1. Then we can use the VM size. Here you can see we have a list of available and not available SKUs. And if you need the big VMs, then you have to create a ticket for Microsoft to increase the quota, and then you can have access to these big VMs like 80 CPU cores, 640 GB of RAM. But for now, I just use the default one, 2 cores and 8 GB of RAM. Then you can say what OS disk you want. I want SSD because it's faster. And then you can select what image you want. So you can pick one from the library. Here we have Ubuntu and Windows. But you could also select from the marketplace, or you can also provide your own image. For now, Ubuntu is good enough. And here you can configure the scaling. But since I'm running out of time, we just skip all of this, go by the default and create this agent pool. And I'm going to stop this video. It's going to take 2 or 3 minutes, and I will be back once the deployment is finished. The deployment is finished, and I think I only have 1 minute left. So we go quickly to the pipeline, and there I've updated the pool to the name of the pool we just created. And then I just have a very simple Docker build task and build the Docker file. Then I'm going to save this, and I'm going to run the pipeline. And now I have to wait a couple minutes. First, I have to approve, since it's the first time I use this agent pool. And now it's going to take a couple minutes for the agent to get started, and then it will execute the pipeline. And again, I'll be back once the pipeline is finished. I'm back, and as you can see, the build of our pipeline finished successfully. This time it took around 2 minutes for the agent to start, and then another minute to build the pipeline. And this concludes my session today. So as you have seen, we have many different options how to host our Azure DevOps agents. But in my opinion, the best option is to use managed DevOps pools. And we also have seen that it only takes a couple minutes to set one up and build your application. Thank you everyone for watching. Again, if you're interested in the slides, you can scan the QR code. And if you want to know more about Azure DevOps and the different agent options, I have more videos on my YouTube channel, and I hope to see you next year.